This one is on codominant traits. Some traits in our body have codominance, which is different than incomplete dominance. A lot of times people get these mixed up and confused. Now with codominant traits, we have two dominant alleles. And I'm going to focus on blood typing as our example for this one because it's a great example for how it's used in our body. It has multiple alleles again, so we're going to have different letters. We're going to have an A blood type, a B blood type, an O blood type, and all those are going to be represented by different letters. Now, in our blood type, we have what's called a clotting factor here. And some people have type A, some have B, some have both, and some have neither. And so that qualifies what your blood type is. We'll talk more about this in class. Now, how we represent this is with blood types in particular, we use this letter I, either capital for dominant or little I for recessive. And that depends on your blood type. I'm going to show you that on the next slide here. So an example of this is type A is dominant, type B is also dominant, whereas type O is not dominant, or it's recessive. So with type A blood, you have to have I with an A like so. And there's two different examples here that you can have type A blood. Because in either case, you have the type A by itself, or you have type A with, if it had a small letter I, it's recessive. So it only exhibits the type A trait. Same thing with B. So A and B are the exact same, except now we have another dominant trait, or dominant allele, type B. Sometimes people get both of those dominant alleles, and so we call them type AB blood types. Sometimes they get neither, they have both recessive, and they're called type O. So AB is the example of a codominant trait where you have both traits, type A blood and type B blood mixed together. So let's look at an example here. We're going to cross a heterozygous type A and a heterozygous type B. So that's these letters here. We have I, A, and the heterozygous means it has the recessive allele, small I. The B person is the same. So now when we set up our Punnett square, so 2 by 2 still, we have IA, IB, we have IB with the recessive I, IA with the recessive I, and then our last option is to have the two recessive alleles. Each of these boxes here, box number 1 is going to be different than box number 2, then box number 3, and box number 4. So if these two people were to have offspring, they have a 1 in 4 chance of getting a different blood type for their offspring every single time. There's a few additional things here that we're going to talk about. And at this point, I'm just going to let you copy these down in your notes if you haven't already. And we're going to talk a little bit about this rhesus factor, which comes from rhesus monkeys. And these two questions here, I want you to think about a little bit. Why is A be a universal receiver, and why would O be a universal donor?